Okay, let's dive right into this explainer and uncover the hidden physical reality of the internet we rely on every single day. We tend to think of the internet as this invisible wireless cloud floating around us, but it's actually incredibly physical. It has a shape, geographical routes, and requires some absolutely mind-blowing engineering. So we're going to explore the hidden arteries of our global village.
Here's a quick roadmap for what we'll cover today. We're going from the great satellite myth to the evolution of optical fiber, exploring this trillion-dollar lifeline, looking at the threats beneath the waves, and finally asking, who actually owns the ocean?
Section 1. The satellite myth. It's time to shatter a pretty massive illusion about how our modern communications actually work.
When you upload a high-risk photo, shoot an email to a colleague overseas or prompt a powerful AI. How do you picture that data traveling? Do you imagine it beaming up into the sky, bouncing off a satellite in orbit and coming back down? It's a completely natural assumption given all the hype around space and wireless tech, but it is incredibly far from the truth.
Here is the staggering reality. A massive 99% of all international data traffic travels not through the sky, but through thousands of feet of dark, freezing ocean water. Satellites handle less than 1%, and the reason why is pretty straightforward. Data in fiber optic cables travels at the speed of light through glass, giving us that ultra-low latency we crave. Satellites are great for really remote areas, but they're vastly slower, way more expensive, and honestly, they just can't handle the immense volume of data our world demands today.
To really wrap your head around the scale of this physical network, get this, there are over 600 active and planned submarine cable lines resting on the ocean floor right now. If you took their combined length, which is about 1.5 million kilometers of cable, and stretched it out, it would wrap around the Earth more than 35 times. It's an absolutely mind-boggling web silently connecting our continents.
Moving on to Section 2, telegraphs to optical fiber. Because obviously, we didn't just build this unbelievable underwater web overnight.
This journey actually kicked off way back in the 1850s with a simple telegraph cable connecting the UK and France. Then, by August of 1858, we managed the first transatlantic cable. And back then, you were waiting several minutes just to transmit a single word. Fast forward to 1988, and we hit a massive milestone. We got TAT8, the very first transatlantic fiber optic cable. Instead of slow clicks and dashes, this thing could carry thousands of phone calls simultaneously. It was a total game changer that ushered in the modern era of light-speed data. But laying these modern cables is no joke. It's a colossal engineering challenge. First, you have these extensive seabed surveys mapping out safe routes, completely dodging earthquake zones, deep craters, and fragile coral reefs. Near the shore where human activity is highest, the cables actually get heavily wrapped in iron armor and buried a meter or two under the seabed. Then, out in the deep water, massive specialized 5,000-ton ships slowly spool out the lines into the absolute darkest parts of the ocean.
Now, even though data is zooming at the speed of light, those light signals naturally weaken over thousands of miles. To fix this, engineers install devices called repeaters every 50 to 80 kilometers along the line. But here is the wild part. These repeaters need power. So right inside the fiber optic cable, right alongside the delicate glass threads carrying your emails, there's a copper wire pumping up to 18,000 volts of electricity just to keep the signal booming across the ocean floor.
Section 3, a trillion-dollar lifeline. We've talked about the hardware, but to truly get why this matters, we have to look at what's actually flowing through these veins.
And this is absolutely crucial. We aren't just talking about streaming 4K movies or sending memes here. These underwater cables are the literal backbone of the global economy. Every single day, over $10 trillion in financial transactions get routed through these submerged wires. If they suddenly went dark, the entire global banking system, stock markets, and international trade would grind to an immediate, devastating halt.
The impact is huge. Studies actually show that when a country hooks up to a new subsea cable, its overall economic activity gets a direct boost of 5 to 7%. That ultra-low latency, light-speed connection lets local businesses plug into global markets, helps governments function digitally, and allows multinational corporations to operate seamlessly across different continents.
Which brings us to Section 4, threats beneath the waves. If our modern civilization and economy rely completely on these really thin wires sitting at the bottom of the ocean, what exactly threatens them?
I'm sure you've seen those viral videos of sharks supposedly chewing on underwater equipment, which makes everyone think marine life is this huge threat. But guess what?
From 2007 to 2014, there were exactly 0 cable cuts caused by marine animals. None. The real danger? It's us. Between 60 and 86% of all cable damage is caused by human activity. We're talking about commercial fishing nets snagging the lines and massive ship anchors dragging roughly across the seabed.
The other major threat is the Earth itself. Remember the massive volcanic eruption near Tonga back in 2022? That blast completely severed the nation's single submarine cable. And because they didn't have a backup, the entire country was thrown totally offline, cut off from the rest of the world for weeks. This right here is exactly why countries and tech companies are scrambling to connect to multiple different cables. Redundancy is everything. Finally, Section 5, who owns the ocean? Let's take a look at how the balance of power over this incredibly critical infrastructure is shifting. Historically, building an undersea cable was so phenomenally expensive that it took national governments or massive consortiums of traditional telecom companies pooling their money to get it done. But look at the landscape today. The demand for bandwidth has skyrocketed so much that private tech giants, companies like Google, Meta, Microsoft, and Amazon, are now the primary investors. They aren't just renting space on these cables anymore, they are literally building their own. Just consider the sheer scale of these modern supercables. You have the To Africa project, which is a staggering 45,000-kilometer cable connecting 33 countries across 3 continents, heavily backed by Meta. Then there's Amitié, pushing a mind-blowing 400 terabits per second, funded by Microsoft and Meta, or Google's Do Not cable linking the US and France. These massive corporations are laying physical claim to the ocean floor just to make sure their data centers can talk to each other without interruption.
So what does this all mean for us? The internet isn't some magical cloud. It is a very real, very vulnerable physical network lying in the pitch-black depths of the ocean. And as more and more of this vital infrastructure falls under the control of a few massive tech corporations, we really have to ask ourselves, who truly holds the power over our global village? Who gets to decide who is connected and who is cut off? Definitely something to think about. Thanks for joining me for this explainer, and keep questioning the world around you.